Hello everyone. From this video, we are going to start a new chapter, chapter 4. And the first section, section 4.1, linearization and estimates. So you can see, first, let's read the second paragraph. The second paragraph from here. Recall from section 2.1 that change between 2 points, change between the first point, c f of c, and the second point, a nearby point c plus h, f of c plus h. So the change between these 2 points is actually the difference between the output values. So that means the change between these 2 points is just f of c plus h minus f of c. So you can see here for h must be positive. So what does h is greater than 0 mean? So we can see the first point c, f of c, for example, c is right here. And the second one, c plus h. So we know when h is positive. When h is positive, c plus h must be on the right side of the c. When h is negative, then we know c plus h is on the left side of c. So here we only assume that h must be positive. So that means the second nearby point, the nearby point must be on the right side of the point c. So the change between these 2 points is just the f of c plus h minus f of c. Then let's go back to the first part. So the first part, still we are given the 2 points, c, f of c, and a nearby point, c plus h, f of c plus h. So the nearby point means h, the horizontal difference. You can see the horizontal difference is just h. The 2 points are super close to each other. That means h actually is a very small number. So we can just say h approaches to 0. H goes to 0. If h is a very big number, then we cannot say c f of c, c plus h, f of c plus h. The second point is a nearby point. We cannot say that. We can only say they are close to each other if the h, the horizontal difference, is a very small number. So for a point c, f of c, and a nearby point c plus h, f of c plus h, on a differentiable function. So on a differentiable function means on a very smooth function. So that means the function cannot be has a hole there, or the function has no sharp corners, or the function, we cannot have a vertical tangent line, then the function is not differentiable. So on a smooth function f, 2 points on a smooth function f, the rate of change we know is f prime of x. Rate of change at a single point, this one, is just f prime of c. The rate of change f prime of c can be used to estimate the amount of change between 2 points. And then f prime of c can also be used to approximate the value of f of c plus h. So from this part, we know we can use the rate of change f prime of c to estimate 2 parts, the amount of change between the 2 points, and also the second part, the value of f of c plus h. So let's check it one by one. How can we use the f prime of c to estimate the amount of change between 2 points? So this part, we know the change between 2 points is actually just here, f of c plus h. Let's change the color. So the blue one is this one. And so we know we can estimate the 2 parts, the blue one, the green one, and the yellow one. The green one is just the f of c plus h minus f of c. So let's use this function graph right here in the corner. We are given a smooth function, f, and we are given 2 nearby points, 2 points, c, f of c. So this is the point c, f of c, and this is a nearby point, c plus h, f of c plus h. So this one, you can see here, for point c, f of c, this is the tangent line. And the right one, this is the secant line between these 2 points. But we know from the second chapter, we know when these 2 points are super close to each other, then actually this line, the tangent line, and the tangent line and the secant line are actually, we can just take them as the same line. We can only use the condition that h, the horizontal difference, is very small. if they are super close to each other, then this line and this line, they are the same line. And then let's see, how can we use the derivative? The derivative f prime of c means the slope of the tangent line at this point. Then we transfer the question, how can we use the f prime of c to estimate f of c plus h minus f of c? So now the question is, how can we use the slope of this one to estimate this one? What is this one? In the function graph, f of c plus h is, you can see, this is our f of c plus h. So this point is c f of c plus h. So we know the vertical part. This is f of c plus h. And what about f of c? F of c is right here. So f of c plus h minus f of c is just this part. So we know this part is our f of c plus h minus f of c. So now the question is, how can we use the slope of the tangent line to estimate this part? We use the information that these 2 points are super close to each other, so we can just use this line, because they are the same line if they are. But in the function graph, I cannot draw that they are super close to each other. Then you cannot see anything. So now we can use the slope of this one to estimate this one. This is an easy question. You can just pause the video and try to figure it out by yourself. How? So because the slope of this one just means this part divided by this part. And we know the horizontal difference is just the c plus h minus the c. So this part is just the h. So what is the value of here? We can just use the slope of this one, which is f prime of c. F prime of c multiplied by this part. Then we got this part. So now we can solve for the first question. The first question, and the answer is right here. An estimate of change between these 2 points. An estimate between these 2 points. So this part just means f of c plus h minus f of h. F of c. So f of c plus h minus f of c is given by that we just talked about the derivative, the slope of the tangent line, or the slope of the secant line, because they are the same one when h goes to 0. So the slope of this one multiplied by the horizontal difference h, then we got this one. And the formula is just, you can see here, f of c, let's change to the same color, not the same one. F prime of c multiplied by h is the, we can use f prime of c to estimate the change between these 2 points. So this is the first question. How can we use f prime of c to estimate the change? And graphically, f prime of c multiplied by h is the vertical distance right here. It's the vertical distance between the point at x equals to c right here, and the second point x equals to c plus h right here. The vertical distance is here on the tangent line to f at the point c. So for the first question, we show the graphically, and this is the formula. And let's go back to the second question. Also, we can use f prime of c to estimate the value of f of c plus h. What is the f of c plus h? In the function graph, we can see this is f of c plus h. So now we can estimate this part, f of the change. So we can just use the first part we solved, plus this part. And what is this part? From here, you can see this part is just f of c. So we can use the answer from the first part. We can use this one, plus f of c. Then that is the value, the estimation of f of c plus h. Then let's see this one. This is the answer for the second question, this part. So you can see the green part is for the first question, and the yellow part is for the second question. F of c plus h is just in the function graph as we've shown, f of c plus h. F of c plus h equals to f of c. This is f of c plus the estimate change. And this change is, we just plug in this one. So now we answer the second question. This formula gives an estimate. This formula gives an estimate of the output value f of c plus h by finding the output value for x equals to c plus h on the tangent line to f at point C. It is found by adding the estimated amount of change to f of c. So this formula, the basic idea of estimation of f of c plus h is to use the first part, the change, plus f of c. And the change is just the basic idea for the change is to, when the 2 points are super close to each other, the tangent line and the secant line, they are the same line. And we can use the idea of the slope. The slope means this one divided by this one to estimate the vertical difference. So for this section, these are the basic parts, 2 parts. How can we use f prime of c to estimate the amount of change? Second part, how can we use f prime of c to estimate the value of the nearby point, f of c plus h? And based on the second formula, we generate a new equation. Then let's see this part. The linearization of a function f at point C is the equation of the tangent line to the function at point C. So this equation can be found using the point slope formula of a line, blah, 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 blah. So the next very important part is the blue part. Oh, it's too dark. Let's change it to crimson orange. So for this formula, you have to memorize it. The formula is called the linearization of the function f at a point C. So what is the function f? In this function graph, it's the smooth function, it's the differentiable function. And then what is the point C? C is the first point, it's not the nearby point, it's the first point, C, f of C. So if we know these 2 parts, then we can use the f prime of c to estimate f of c plus h by using the formula, this one. So you can see here, what's the difference between this formula and the formula we are given here. So you can see here, the first part, x, if you, alright, let's rewrite this formula. This is f of c plus h is f of c plus f prime of c multiplied by h. Alright, so now let's say this term c plus h is x, c plus h is x. Then f sub l x, c plus h is x. And the first term is a c, we don't have h, so we don't have to change it. And the second part is this part is the same. We don't have x, we don't have to change it, c. We don't have h, so it's still f prime of c. But this part, we have h there, and by using this one, we know h is just x minus c. So we just change h to x minus c. So you can see this is exactly the linearization of the function f at point C. For this formula, you have to memorize it and pay attention to the notation, because this formula is called the linearization of a function of f at point C. So you have to use this function is f sub l of x. So don't forget the l here. This formula is called the linearization of a function f at point C. Alright, so next let's try to do example 1 together. Example 1, as in this function graph, we are given first one, g of 10 equals to 5, and the g prime of 10 is 2. G of 10 is 5. G prime of 10 is the slope of the tangent line, is 2. So the first question, approximate the amount of change between g of 10 and g of 10.7. So g of 10, this is g of 10. G of 10.7, this is 10.7, so g of 10.7. And we are looking for the vertical distance. And the amount of change between these 2 points is just g of c plus h minus g of c is just a g of 10.7 minus g of 10 can be estimated. So let's go back to the formula. We use the first one. We can use f prime of c multiplied by h. So this part f prime of c multiplied by h, and the c here is just a 10. So this is the first point c, and this is the second point c plus h. So we know c is 10. We just use the formula. C prime f prime of x multiplied by h. So here we are given the function g, so it's just a g prime of c multiplied by h. C is 10, so just a g of 10 multiplied by the horizontal difference. It's just 0.7, so h is 0.7. So that is how we got this one. And what is g prime of 10? G prime of 10 is right here. It's 2. And then what about the g prime of, excuse me, this is g prime of 10, and then multiplied by 0.7, just the 1.4. And this is the first question, change, estimate of change. And the second question, estimate of the output value. We have to use f of c. All right, let's go back to the second question. The output value of g of 10.7. So, okay, this is not about the linearization. This is just about the second formula, the second question. So we use this one. Let's write it here. F of c plus f prime of c multiplied by h. Then, for this one, this is you have to change it to g. This one is equals to, because we know c equals to 10. And c plus h equals to 10.7. So by plugging this formula, by using this formula, we have g of c, that is g of 10.7, equals to f of c, that is g of c is 10, plus g prime of 10 multiplied by the h is this part, that is 0.7. That is 0.7. All right, so you can see here. Sorry. Right. So now we have this formula. G of 10 is G of 10 is here. G of 10 is 5. And the G prime of 10 is 2. So we use the 2 multiplied by 0.7. That is just the 6.4. Or, because here we can just say estimate change. What is the estimate of change? It's actually A. So you can see here A. So actually, instead of using this formula directly, we can just use A. That is just 1.4. That is the estimate of change. So actually, the second part of the question is just the f of c plus the first question. And this part shows you f of c, g of 10 plus the first question is the 6.4. So that's how we got this one. And the next question C, the estimate in part B is underestimate or overestimate. So for this one, let's go back to the function graph. In the function graph, we can see, all right, this function is concave down because this is the function concave down. And what is the B? What is our estimation? Our estimation, we know this is the tangent line. So by using the formula, we know our, actually, the estimation is f of 10. This is f of 10 plus the slope of the tangent line multiplied by the vertical distance. The vertical distance is right here. The slope of the blue line multiplied by this part. Oh, excuse me, not this part. Multiplied by the horizontal, this part. So the slope multiplied by this part is actually this part. Then we use this part multiplied by this part. So our estimation is actually this one. This is our question B. So you can see this part is question B. And what is the real function value? What is the real g of 10.7? Because question B is only our estimation. Estimation means that's not the real thing. So what is the real function value? We have to use the function graph. This is the function graph. When x equals to 10.7, the real g of 10.7 is right here. So that means the blue part is the real function value. This is the real function value. This is the real g of 10.7. So you can see our estimation is right there. The function value, the real function value is there. So actually, we are overestimate. That is because our estimation is higher than the real function value. So we are an overestimate. And because the function is concave down, So similar, if the function is concave up, then you can see the tangent line is below the function graph. Then that means our estimation is underestimate. But for this one, because the function is concave down, for the concave down, all the function that is concave down, the corresponding tangent line must be above, like this one. The tangent line is above the function graph. So that's how we got overestimation. If it is the concave down, if the function is concave up, then we are actually underestimate. If the function is concave down, then we are overestimate. Question D, write a linearization. Linearization is different from the... Actually, for this one, we have 3 formulas. The first formula, the second formula, and the linearization formula. Linearization is formula. The linearization formula is different. First one, the notation is different. It must be a sub L. L means the linearization, and then this part is slightly different. Then write a linearization function for this one. First, let's just use the general linearization formula. G sub L of x is actually g of c plus g prime of c multiplied by x minus c. Then in this one, we know c is just c is 10. C plus h is 10.7. So we plug in the number. G of c is 10, so g of 10 plus g prime of 10 multiplied by x minus 10. G of 10 is just g of 10 is 5, g prime of 10 is 2. So we have 5 plus 2 times x minus c. X minus c is just here, c is 10, x minus 10. So you can see the linearization. This is the linearization function. A linearization formula is actually a equation. Is actually a function of x. It's not a number. But our estimate, like question A and question B, ask you to try to estimate the change or try to estimate the output value of g of 10.7. The answer, you must have got a number. But for the linearization formula, for a function, for a g of x at c equals to 10. Or for this one, we don't have to use this graph. We can just plug in c equals to 10 from here. This is the general formula. C equals to 10, plug in c equals to 10. Then we have this one. So for the linearization, it must be a function. Then what about the next one? You can see D is the linearization. E is to use the linearization in part D to approximate g of 10.7. So that means we have to use this formula to estimate when x equals to 10.7, what is the corresponding g sub L of 10.7? We just plug in x equals to 10.7, then we have 5 plus 2 multiplied by 10.7 minus 10. And then we have 6.4. So you can see the difference. A and B, they are the two parts can be estimated by using f prime of c, g prime of c. And the D is a linearization, that is a formula. E is we use the linearization from part D to estimate when we are given the value of c is 10.7, what is the corresponding G sub L of 10.7. So that's all for this section actually. And then next though, please pause the video and finish example 2. Alright, for example 2, 2a, we are given f of 3 is 17, f prime of 3 is 4.6. Write a linearization for f when we are given the input value c is 3. So f sub L of x is just the f of c plus f prime of c multiplied by x minus c. And we are given c equals to 3. So f of 3 plus f prime of 3 multiplied by x minus 3. And f of 3 is given 17 plus f prime of 3 is 4.6. Then this is the formula. The next one, use the linearization to estimate f of 3.5. So f sub L, pay attention to here. You still have to use f sub L. You cannot just use f of 3.5. You still have to use f sub L 3.5 equals to 17 plus 4.6. Just plug in x equals to 3.5 minus 3. Then we have 19.3. Then we are done. And the homework for this section is to finish example 3 and example 4. And then still, please send me a picture of these 2 questions. You are gonna get full points as long as you finish these 2 ones. And I'm gonna post another video about these 2 examples. And feel free to let me know if you have any questions. That's all for this section 4.1. Thanks for watching. Oh, by the way, if some students, they don't have the textbook, so I'm gonna just alright, I'm gonna post the PDF version of the question 3 and question 4. Thanks for watching.